In today's video, we're going to look at how the internal energy of an object relates to its temperature, using the concept of specific heat capacity. Now, the first thing we need to do is take a look at a few terms. Internal energy is the total energy that's stored by the particles making up a substance or system. And we often talk about it as if it's made up of two parts: the potential energy stores and the kinetic energy stores. The potential energy stores are things like gravitational and elastic potential, but they're not really related to temperature, so we can pretty much ignore them in this video. On the other hand, kinetic energy is the movement energy of the particles, and this is the one that's important. Whenever you heat up a substance, it transfers energy to the kinetic energy store of all the particles, and so increases their internal energy. We measure this as an increase in temperature, because temperature is just a measure of the average internal energy of a substance. So the more internal energy that a substance has, the higher its temperature will be. However, some materials require a lot more energy to increase their temperature than others. For example, water requires 4,200 joules of energy to warm 1 kilo of it by 1 degree Celsius. Whereas 1 kilo of mercury can be heated by 1 degree Celsius with only 139 joules of energy. We call these numbers the specific heat capacity, which is the amount of energy needed to raise the temperature of 1 kilo of a substance by 1 degree Celsius. It can also be thought of as the amount of energy released as that substance cools. So each time our kilo of water cools by 1 degree Celsius, it will give out 4,200 joules of energy to the surroundings. We can put this idea into an equation where the change in internal energy is equal to the mass times the specific heat capacity for that particular substance times the change in temperature, with the triangles meaning change and the zero, the line through it, being a theta sign, which here means temperature. To see how this works, let's try a question. Find the final temperature of 800 grams of water at an initial temperature of 20 degrees Celsius after 20 kilojoules of energy has been transferred to it. The specific heat capacity of water is 4,200 joules per kilo per degree. Well, in order to find the final temperature, what we're really looking for is the change in temperature. So to get that term by itself, we need to divide both sides by mc, giving us energy divided by mass times specific heat capacity equals change in temperature. Next, we make sure all of our units are correct. So change 800 grams to 0.8 kilos, and change 20 kilojoules to 20,000 joules, and then plug these values into the equation. So overall, we get a temperature change of 5.95 degrees. And if we add that onto our original 20 degrees, the final temperature would be 25.95 degrees, or 26.0 degrees if we round it to 3 significant figures, which we generally should. One thing to point out here is that in real life, the temperature probably wouldn't actually increase this much, because some of the energy would be lost to the surroundings, mostly in the form of heat. So if you're going to do this experiment in a classroom, you'd want to make sure that you used a lid and that you insulated it well.